Hello everyone and welcome back to another video. Today, what we're going to be discussing are various evidences for evolution. So like we said before, evolution is a theory, and for a theory to be considered that, there has to be evidence for its support. So today we're going to talk about some brief evidences for evolution. You should have covered this in your evidence for evolution packet, but consider this just kind of the Spark Notes version of what you covered there. Let's get started. So evidence supporting evolution. The first is the fossil record. So the fossil record shows changes in organisms over time. There's the anatomical record, things that go ahead and compare different body structures. Things like homology and vestigial structures, as well as embryology and development. And finally, we have the molecular record, which is comparing protein and DNA sequences. The more similarities, the more closely they're related. So if you go ahead and take a look down here in the bottom right, we have a little chart. So these are the number of protein differences between organisms. Between humans, there's 0. Between humans and gorillas, there's 3. And between the human and the eagle, there are 15. So that being said, we can clearly define that humans are more closely related to gorillas than they are eagles. So the first structure type I wanted to go ahead and talk about today were homologous structures. So homologous structures are structures that came from the same origin. So homo meaning same, logos meaning information. Some examples of this include the forelimbs of humans, cats, whales, and bats. If you go ahead and take a look in the bottom right-hand corner here, you'll notice that they all have the same bones. They're just arranged in different ways, different sizes and different shapes. So like we said, they have the same structures on the inside, as well as they have similar development when they're embryos inside the womb. However, each serves a different purpose. A human's forelimb is used for going ahead grasping things, high-fiving, and punching. A cat, pouncing. A whale, swimming. And a bat, flying. So they have different functions on the outside, but a similar structure on the inside. Now this is what we call evidence of a common ancestor. So it's safe to say that at some point these individuals had a recent common ancestor. However, this is evidence of what we call divergent evolution. So to diverge means to split, meaning that even though they had a common ancestor, at some point they split from that common ancestor over time. Now, the next bit here are analogous structures. Now, even though analogous structures look similar on the outside, and even have the same function in most cases, they have a different structure and different development on the inside. So, even though the wings of both eagles, or sorry, not eagle, this is a falcon. Even though the wings of a falcon and the wings of a dragonfly are both used for flight, and you could even go ahead and make the claim that maybe they look similar, they have a completely different structure and development. So for example, most birds are born with their wings. They're not very developed. But most insects like dragonflies are actually born without their wings, and they go ahead and gain them through molting over the years. So these have a different origin, and we call this convergent evolution. So convergent means to come together. So in this case, organisms are adapting similar solutions to similar problems. Now, there is no evidence for a recent common ancestor with these individuals. So analogous, no recent common ancestor. Homologous, recent common ancestor. So convergent evolution, analogous structures. Like we said, if you take a look, we have a bat, an eagle, I keep saying that, that's a falcon, my apologies, and a dragonfly. Even though they all have wings, there probably isn't a recent common ancestor between the three. Now, if you wanted to only say between the falcon and the bat, maybe. There's a much better chance of that, considering they both have bones inside their suggestive wings. So convergent evolution just means evolving similar solutions to similar problems. So let's do an example here. We have a dolphin and we have fish. So dolphins are aquatic mammals. Fish are aquatic vertebrates. Both are adapted to life in the sea. However, they are not closely related. So these would be more analogous, so evolving similar solutions to similar problems. Finally, let's go ahead and talk about our last two bits of information here: vestigial structures and embryology. So vestigial structures are structures that have lost their purpose over time and now don't really have much of a job. For example, the human tailbone. We don't really have tails, yet the coccyx is there. Also, did you know that whales actually have hips? Why would they have hips unless at one point they had legs? It doesn't really make much sense. But anyway, so they've kind of lost the purpose over time. The next bit is embryology. So organisms have similar structures while developing and tend to be closely related. So if you take a look here, between all of these organisms here, a shark, a lizard, a chicken, a pig, and a human, there's actually a common ancestor here considering we all have gill slits while we're embryos. Just food for thought. So if they look similar while developing, there's probably a common ancestor in there somewhere. And that is going to go ahead and close up shop for today. This was a brief little summary of everything that we discussed in the packet. So if you would like a bit more information on this, please go ahead and consult your packet and consider them your notes on this subject. So with that, that's going to close up shop for today. Thank you very much for your time. And until the next time we meet, you go ahead and take care of yourself and have a good one. See ya.